And so, under the aegis and in the presence of His All Holiness, the Ecumenical Patriarch, I'll ask Graeme Kelleher to represent the Prime Minister of Australia.
Your All Holiness, Ecumenical Patriarch Bartholomew, Your Eminences and distinguished participants, dear friends and mates, it is with great regret that I confirm the inability of His Excellency Mr. Kevin Rudd, Prime Minister of Australia, to attend this symposium. He has expressed great interest in this and all future symposia of religion, science and the environment. However, the global and Australian national crises which we are encountering at present have placed such demands on him that he has been unable to accept the invitation from His All Holiness. Mr. Rudd has consistently expressed his concern about climate change, its probable effects on the biosphere and Australia, and the need for all nations of the world to cooperate in reducing the production and dissemination of greenhouse gases. As he said in his address to the 64th session excuse me, of the United Nations General Assembly in New York on the 23rd of September this year, quote, "The truth is, all governments need to reach beyond their self-interests and instead fashion a grand bargain between the developed and developing countries of the world, a grand bargain which embraces both historical and future responsibility, a grand bargain which is anchored in the science of climate change and the need to keep temperature rises within 2 degrees Celsius to avoid catastrophic climate change, a grand bargain which embraces the 3 great challenges of climate change which we are yet to resolve. They are, first, what binding targets and commitments developed and developing countries must adopt to keep temperature rises within 2 degrees Celsius. Second, what public and private climate change financing arrangements are necessary to support mitigation and adaptation measures we need to implement in the future. Third, what technology transfer we need to undertake in renewable energy, carbon capture and storage, energy efficiency, and the avoidance of deforestation and forest degradation to bring about real reductions in greenhouse gas emissions. In the period ahead, the grand bargain we must strike needs to resolve all 3 of these challenges, as each is inextricably dependent on the others. We must make use of all available mechanisms for international cooperation, including the Major Economies Forum and the G20, to achieve success in these negotiations. For us all, this will be a test of leadership. Leadership which seeks to lift our collective vision beyond today and instead focus on the needs of tomorrow. But time is short. End of quotation. Mr. Rudd pointed out that there remained only 74 days from the time of his United Nations speech until the Copenhagen conference, and that the governments of the world were far from agreement. This means, ladies and gentlemen, that from today there are only 45 days until the Copenhagen conference. It seems to me that we need to apply the wisdom underlying the concept of these symposia, for which we thank particularly His All Holiness, the Healing Patriarch, to ensure that dramatic action is taken at Copenhagen and subsequently. The fundamental strengths of the passion and morality of religion, combined with the knowledge provided by science and applied through technology and communication, are the main hope for the peoples of the world to act in concert to protect the living planet on which we all depend. The world is already observing the dramatic increases in extreme temperatures, storms and droughts predicted by sophisticated climate models, which take into account the effects of global warming. These events exceed those predicted by the worst-case scenarios of the International Panel on Climate Change. As a citizen of Australia, let me give you some information about that country and the probable effects on it of climate change. I do this not in order to exaggerate the importance of that little country, but only because I'm most familiar with it. Australia is the world's driest inhabited continent. Of all the continents, only Antarctica is drier. Forgive me, I realise that I have been excessively focused on human beings because Antarctica is inhabited, but not by human beings. The area of Australia is approximately that of the contiguous United States of America. It has a population of only approximately 25 million, but it feeds about 75 million people. The consequences are predicted and already evident reductions in rainfall in Australia for the production of food for the inhabitants of Australia and for other countries will be very great indeed. As one example, approximately 40% of the food produced in Australia is grown in the Murray-Darling Basin. The length of the Murray-Darling River is approximately 3,780 kilometres, which is only about 30 miles longer than the Mississippi River. However, the average flow at the mouth of the Mississippi River is 650 times the average flow at the mouth of the Murray-Darling River. Does that give you an idea of the relative aridity of our country back there? Just a few more than 2 million people live in the Murray-Darling Basin, and most of the food is produced through irrigation of various types. The last few years have seen a dramatic reduction in rainfall in the whole of the southeast of Australia, so that the Murray-Darling River now discharges, but it is now banked by a sandbank, which it does not naturally go through, and it has to be dredged. That gives you an idea of how low the flow is and how dramatic the problem is. Models show that this reduction in rainfall will increase as global warming increases. The Murray-Darling will dry up and its food production capacity will collapse. The basin will be able to support far fewer people, perhaps no one outside Australia, and perhaps only a total of 200,000 people, not 40 million. As another example, Australia has seen, as of other countries, a marked increase in the frequency and magnitude of droughts and flooding rains, of uncontrollable bushfires destroying communities, of cyclones in the northeast, and of the incipient spread of tropical diseases southward. The world icon, the Great Barrier Reef, is threatened by increasing sea temperatures, leading to bleaching and death of corals, and a reduction in their ability to compete with algae in the increasing nutrient levels and acidity of the ocean. The Great Barrier Reef is perhaps the most biodiverse ecosystem on the planet. It generates over $5 billion Australian dollars per year in tourism, let alone fishing and other industries, which demonstrates its attractiveness and value to people from all parts of the world, not just Australia. Taken together, all of these terrible changes will accelerate without dramatic action by all the peoples of the world. But Australia is only one example. As Mr. Rudd has pointed out, quotation, time is already running out for the island states of the Pacific. Coastal inundation is not a prospect, but a fact. 50% of the population of these island states reside within 1.5 kilometres of the coast. And that's why Australia nationally and globally stands ready to play its part in acting on this great moral, environmental and economic challenge of our age, end of quote. He should have included scientific challenge. Distinguished delegates, it is my honour to present to you this summary of the likely effects of human-induced climate change on Australia as an example of the effects on most, if not all, of the countries of the world. I hope that these and related predictions will encourage all of us to use our commitment, wisdom for those of you who have it. I do not claim wisdom myself. Knowledge and care for our fellow humans and the biosphere to influence the world's leaders, communities and the members of all of those communities to take individual and cooperative action to save our planet. These symposia, with which I have been proud to have been associated since their inception, are a major source of inspiration for us all to contribute to attaining a sustainable world. Thank you, and see you, mates.
Graeme, thank you, and thank you for your own contribution, but also representing Kevin Rudd. Australian friends say that the election of Kevin Rudd was Australia's Obama moment, and it's really changed the atmosphere. Now, we're fortunate to have Dr. Robert Correll. You have a biographical description of his very distinguished career in the handbook, but I just note the fact that Dr. Correll won the Nobel Peace Prize in 2007 for his extensive work with the International Panel on Climate Change Assessments. And so we're very fortunate indeed to be able to welcome Dr. Correll.
Thank you very much. Your Holiness and Your Eminence, colleagues and friends, are really honored to join you and be back with you this afternoon. If we could have the slides on the view graph, we can then begin. I guess you don't need images of me. You can see me. Can we have the PowerPoint? What did it do? It didn't do the detection. It was running before. Yeah.
Okay, yeah, maybe this was just loose.
I think we're ready to go. Apologize. Technology occasionally even. I'd like to talk about the scientific foundations and how they play a role in policy development for our nations around the world, and how it might lead us to Copenhagen. And I'd like to share with you at the end some of the prognosis that the science community is sharing with you to this day, and like to think of this as a conversation as we gather here at the podium to discuss this with you. We're going from the Arctic, Your Holiness, where you brought together us over what we know is happening in the Arctic, the bellwether of our world, and brought us here to the Mississippi so that we can address the kind of thing that Kofi Annan said so eloquently, which I'll let you read in the background. It is really an issue far beyond the environment alone. It's about human well-being. It's about economic stability. It has so many dimensions which were discussed in great detail, Lord Bishop, yesterday as we understand the future. So it was Kofi Annan who laid down these words, which are almost a catechism for many of us as we work together. How is it that we understand about the world on long time scales? We know for at least 2.5 million years, the Arctic region has been in an up and down phase of periods of very cold, glaciated planet on the top, And at various times quite warm and other times even quite cold during what we call the interglacial period. And it is these ice cores that allow us to get all these kinds of information from captured within the ice itself to little tiny bubbles that are capturing the atmosphere as it was frozen at the time of the snowfall and conversion to ice. So I think you can see here one has a remarkable library, if you will, of how the planet's behaved on long time scales. But something very special has happened over the last 10,000 years, and if you'll notice over to the right there, that band is wider than any of the other peaks. And if we even went back 1,000,000 years, we would see that same pattern. And it is that period of time where humans have had the privilege of having a very stable climate. That blue band is less than a degree centigrade, and yet within it we've had some warming periods, the Mesopotamian, we had the medieval warming, but we even had the Little Ice Age. And it is that 1 degree that matters so much. It sort of ought to be a hallmark of our conversation. 1 degree matters. And if we ask ourselves, how are we doing? What's happening to us? Those are the various scenarios that the IPCC has put forth over the last decade. The upper one is what we call business as usual, or worse still, it is the worst case scenario that the IPCC scientific community, working with governments, could outline for us back in 2001. You'll notice the little red dots. They are outside the worst case. So we're not making much progress, even though we've had the Kyoto Protocol. And here's the reason why. Over the decades suggested there, we keep putting more and more carbon dioxide and other greenhouse gases in the atmosphere. And you can see as we get to the bottom of this list, we're almost putting 25 ppm, parts per million of carbon dioxide in the atmosphere every decade. And as Lord Bishop said yesterday, it won't be very long because we're way beyond that 450 number that everybody is talking about as sort of the upper limit. Some of us in the science community think that's even beyond which we should be. And it's this reason, there's an acceleration going on, and you can see the numbers. Just in a decade, we put 4 times as much in the atmosphere as we had in prior decades. And so these are really not good trends for us as humans on the planet to understand that we know the problem, we understand the problem at least at a cursory level, and yet our inability to come to grips with it is what we're here to talk about, in my view. And that's where we're headed. The IPCC suggests that by 2100, we're going to have temperatures that are of the order of 1 or 2 degrees all the way up to 6. But the 1 degree is an optimistic one, and the 6 degrees is this worst case business as usual perspective. Where does all that carbon dioxide go? Most of it goes into 3 places. It comes, about 80% of it comes from fossil fuels. The other 20% comes from the destruction of the rainforests in the tropical regions. There's a problem, however. It goes to 3 places, and the 2 that would be helpful to us, namely the ocean and the land, have begun to saturate. Over the last couple of decades, they are less able than they were before to absorb, and that means more is going to go into the atmosphere. So we have this feedback mechanism that is accentuating the problem because the 2 that could take up some of the CO2 are no longer able to do so. There's been a lot of talk about we might have a cooling period for a decade. I'd just like to show you a few slides and let you draw your own conclusions. There's the northern hemisphere temperatures over the last 100 plus years. There are these repeated stories in the press about it. These are now on the same time scale. That's the southern hemisphere. The southern hemisphere is warming much less, by quite a bit, than the northern hemisphere. You can see the numbers on the left, all the way up to 1.2 degrees centigrade in the north, and much less, maybe half of that in the south. Both of which are continuing to warm. Here's what's happening. In the mid-latitudes, in the tropic latitudes, there appears to be a cooling effect. And the reason for that is that the El Nino process and then the La Nina process have a tendency to slow things down. I could show you year after year, decade after decade, over hundreds of years, that whenever we have a warming of the relative warming, we get all these spikes, you'll have a strong El Nino. Whenever it's quite cooling relatively, it's when we have the La Nina. Here we are, Lord Bishop. You made the comment yesterday of a photograph of our planet. This is from 800 million miles away. If you ask how long did it take the light to get from that planet blue, by the way, this has not been doctored by Photoshop. That's the actual photograph. It's still blue, the blue planet. And what I'd like to do is explore with you some of the implications of our only known spaceship upon which we humans have the privilege of living. I'd like to say a little bit about the oceans. There are lots of things we could say about the oceans, and it would be wonderful to explore them during the question period, but I only want to focus on a couple things. These species all are based, their lives are based on calcium. Calcium exoskeletals around them that form it, the coral reefs are all calcium-based. And here's what's happening. We're finding that even at the lowest level of life, in the ocean, phytoplankton, small, tiny, almost single-cell plants. At the current position that our planet's in, they're gorgeous. They're like snowflakes. Every one of them is virtually different. They're gorgeous. But we know that as the ocean sees more and more carbon dioxide sitting on top of it, nothing to do with temperature, that's what's happening. For 25 million years, we've had a very stable set of carbon dioxide sitting on top of the ocean. And the reason for that is its ability to kind of adjust itself works on timescales of about 10,000 years. We're changing things on timescales of hundreds, a few hundred years, and that's what's happening. And these calcareous-based species are the bottom of the food chain. Everything here ultimately works its way to whales and into the food chain of humans. So we're threatening it because as that carbon dioxide sits there, it's absorbed by the ocean and is made into carbonic acid. And that carbonic acid then attacks the calcium-based structure of these species. So the Great Barrier Reef and others are going to be even more stressed by the increase of what we call the acidification of the ocean. And it is independent of all these talks about sea level rise and temperature rise. The mere existence of carbon dioxide sitting on top of the ocean causes it. But let's run ourselves into the Arctic and revisit, if you will, Your Holiness, some of the things that we observed only casually before have now, even in 2 years, become much, much more detailed. It is a region that is not only attacked by climate change, but a lot of culture change, a lot of globalization issues, even high concentrations, as was noted by Patricia Cochran yesterday, of PCBs and heavy metals. Even ozone depletion is a problem up there. But here's the picture of the Arctic. These are the temperatures. This is only about 2 weeks old, probably the best data set we have, and we're really screaming out, and if you like to know what the total is, there it is. In about 140 years, we've gone up well over 2 degrees. Remember, 1 degree matters. Here's the other problem for the Arctic. This is what the permafrost looks like right now. It's not melting very much, some. And you can see here, if you could see the scales, there's modest, but we're going to go to 2050, and suddenly we're now seeing regions that are melting, and that sort of reddish maroon is what we're seeing. And here's where we're headed. The permafrost thawing will be ubiquitous, and what's buried in that permafrost, both on land and beneath the sea, are huge quantities of methane. But the common name for methane is natural gas. It's what's mined and drilled for around the world and is distributed for many reasons, mostly heating. So you can begin to see the locations in which permafrost is going to be a real problem. And this is what's happening now. This is a picture of a little lake in northern Russia, and merely a hole punched in the lake. That's methane coming out, and a mere match is enough to to light it off. So methane's a problem for us. It is 22 times to 25 times more effective as a greenhouse gas than is CO2. So we don't want much of it. And the only way to stop it once the planet gets too warm is to take the whole planet and put it in a refrigerator and lower its temperature again. That's the only way to stop it because it's ubiquitous, it's everywhere. This is one to worry about, and I worry about it just like acidification of the ocean are two serious problems that we do not want to ever confront. This is what's happening to the Central Arctic Ice Basin. Back in 2004, it was mentioned yesterday, we had these grand predictions that it would probably be ice-free by the end of the century or maybe beyond. Unfortunately, Mother Nature and the planet behaves differently, and you can see the data points. We're roughly half the size of ice that we had in 1979 in this past year. And this is kind of what it looks like, real time, starting in January and going through September, which is the time at which we get the least amount of ice. And you'll see it here fairly slow. We're going through day by day, and you start to see it pulsate, melt off, just like ice on the window of your car. As it gets warmer, it gets smaller and smaller and smaller. And suddenly we're opening up seaways on the Canadian side and on the Russian side, and you can see it's wide open now. And that's what it looks like. The Canadian archipelago had never in known history been wide open to sea travel. It was for 2 weeks last year. On the Russian side, it's wide open and has been for the last several years. That's what it's likely to look like in a decade or two, something of that nature, in September. It'll be like many of the lakes that we all know in northern parts of our own countries where they freeze over in the winter and melt in the summer. Totally changes the character because multi-year ice is gone. Multi-year ice harvests all kinds of different characteristics, some major thicknesses, but changes the biota as well. It also changes something fundamental. And that is, with all that ice and snow, we have mirrors on the top of our planet, reflecting back 80 to 85% of all the incoming energy is re-radiated back out. But when you take the ice away, it looks like a black body. The ocean and the land both absorb 85. So it's another accelerator, making things happen more rapidly than other than the case. The amount can be depicted here just from 1980 to the present. The amount of ice lost, you can see for yourself, are major parts of the continents of which we are all aware. This is what's happening to Greenland. Just been there only a few weeks ago myself again, and seeing firsthand the kind of things that are happening in Greenland. I like to take you to this little part of Greenland on the western part called Ilulissat, the Ilulissat Glacier. That's about 70 kilometers, that little finger you see, and we're going to go up to the face of that glacier. We could go into it. These are all icebergs. The tip of that iceberg on the right is 100 meters off the water, which means it's 700 meters below the water. It's huge. Gigantic pieces are coming off, and here's how they're formed. And we've been forming glaciers like this, icebergs, but they're being formed 3 to 4 times more rapidly than in the history we have recorded by the science community. I'll show that again, just to give you some. That's over 1 kilometer wide, 900 meters tall, about 500 meters. It's like a whole city block in New York, except 3 times taller than any of the largest buildings in the world. Where does that water go? That's melted into the sea. It goes to sea level. These are the latest projections. This is, again, only about 2 or 3 weeks old papers. It's now pretty clear that we're going to look more like 1 meter of sea level rise or more towards the end of this century, because IPCC, in its projections, forgot or elected not to include in the projections the melting of the ice in both Antarctica and Arctic and others as well, because we had a real ability to do predictions. But in the 4 years since IPCC froze its analysis, we've gotten more and more information, and these projections, I think, are still conservative. So that's about 1 foot every 20 to 25 years. So every generation of our species will see that. That's what it does to Florida for 1 meter. It affects, as you heard so eloquently from Patricia yesterday, the indigenous people around the planet. So it's happening dramatically. But what can we do about it? And this is the part that I'd like to share with you as we all walk towards Copenhagen only a few weeks ahead. We have a team of people who have the capacity to run very rapidly climate models to project what it is that the nations of the world might be willing to do, and to project the outcomes of those projections based on what publicly nations are saying, and I'll walk you through it. Sea Roads is a climate model. It models the CO2, it models all the other things, the forests, it takes care of the other greenhouse gases, and it predicts all kinds of things like sea level rise, temperature, and the like, and I'll give you a window on that. And it's done a good job of replicating all of the IPCC. As you can see here, these are the replications on big supercomputer runs that this model, which actually runs on this laptop computer that's sitting here before you this morning. You can't read this, but these are the 25 positions that nations have said they wish to take to Copenhagen. All of the other 192 less 25 are going to Copenhagen with business as usual. We're going to do what we've been doing in the past. Now, we'll see some more over the couple of weeks ahead. In fact, in 1 month, this went from 15 to 25. Some of you can see some of these. But it includes all of Europe going at 80% reduction by 2050, the United States doing the same. Now, we take that and we run this computer model. All right, what's happening here? Okay, we run this computer model because we take all of that information in about what nations are doing, not only with CO2, but the other greenhouse gases and deforestation and the right. And out of it, the model will produce CO2 in the atmosphere, sea level rise, and the like. And that's what you get. Remember, this is what the nations going to Copenhagen are saying. We're going to drop from about 950 ppm to about 700. You've heard us mention 450 over and over again. There are many of us believe that 450 is too high. For some reason, it's decided to give me a hard time. Here's the temperature. We're going to have a 3.5 or 6 degree Fahrenheit warmer planet. And the projections on this are different from scenarios because we know what people as nations are saying they want to do, are willing to do. I would call this the optimistic projections, knowing that the US has yet to pass a law of any kind that will take us onto cap and trade or any other mechanism to reduce it. So I would argue these are optimistic projections. There's sea level rise. You'll say, gosh, it took us from 950 down to 700. It's only changed sea level a little. And the reason for that is simply that it takes a long time to melt. And you'll notice that the slope of that curve is still going up. It will take hundreds of years at elevated temperatures to stabilize the sea level rise. The last time we had temperatures of the nature we have actually today, we saw between 2.5 and 3.5 meters of sea level rise over several hundred years. So we're on a path that makes Bangladesh and the small island states, and this one is right here. There is 1 meter of sea level rise for where you're sitting today, based only on the topography, only going where the 1 meter line is on the land. It does not include storm surges and things of that nature. I won't go through this in any detail, but this is why it is you want to be worried about it. It affects water, affects ecosystem, affects food, affects coasts, affects the whole world. And you'll notice that almost all the lines with all the little details that you can't see are all originating before that 3.5 degree line. So we're headed to a planet that's probably a very different one than any time in human history. It could be 450, it could be 550, but it's a blue band that's outside anything humans have ever seen during the modern history of the humankind. And I'm talking about the last 1,000,000 years. Because as we all know, humanity as we really know it is a 10,000-year-old enterprise. That's when agriculture was invented and all the goodies that we all know about from the histories we have learned about. So there we are, planet Earth, 800 million miles away. And it's not just an environmental issue. It's an issue of equity for human well-being. Is a policy challenge not only of this time, but in my opinion, in the history of humans as we know it. Thank you.
Thank you for those results of really recent research, which certainly are new to me and I imagine to some of the less expert members of this symposium. I expect I speak for everyone when I said I found that a most extraordinarily clear and sobering presentation, and it's one that we ought to feel really charged with some energy if we realize what the scenario you've painted is. I think